problem in Bandung City. And I will say that some of the implication come from the land conversion due to the urbanization in Bandung City. It caused like 90% of the rainwater could be infiltrate well to the soil, and it's caused land subsidence, drainage failure, and many other problems that causes vulnerability in hazard and drought in Bandung City. And then uh, the Bandung municipalities is also have implement the structural efforts for the mitigation for flood and drought. As you might see here in the presentation, there are six retention ponds, two water basement, and many other structural efforts. But unfortunately, it still cannot overcome the problem of floods and drought in Bandung City. And that's why in our research, we want to know how could it be and how could the all of the structural efforts could not resolve or the problem of floods and drought in Bandung City, as the aims of this research is to understand people knowledge and attitudes toward disaster, especially in the drought and flood in Bandung City. And we also want to know about the public acceptance of the existing programs that have been implemented by the municipality of Bandung City. And the methodology that we use is that we use the one online self competition questionnaire, which use the random sampling, and secondary methods that we conduct for adding the support data from the journal papers or the policy that have been implemented by the Bandung authorities. And we, for the data analysis, we use the qualitative analysis to know how could the phenomenon happen, and the descriptive quantitative for descriptive quantitative for knowing how to interpret the statistical data that have been conducted for this research. And for the result and the discussion, as you may know, I've said before, the retention pond have and the drum pores is one of the biggest measures that have been implemented by Bandung municipalities. However, for floods and drought has a lot of uh, problem that cannot resolve by the current measures that have been implemented. And for the respondent that have been that we have been interview or filled our questionnaire, this is like the characteristic, and most of them have been affected by flood and drought in Bandung City. And for the public risk perception, we have like four factors that we determine here. The first one is knowledge. The knowledge for the Bandung cities communities, the the knowledge is the understanding of the flood and drought is already really they have known about the major cause and the major cause of flood and drought. However, the awareness for the current risks that have been faced by them is quite high, and the current possibility and the future worsen severity is really high in the percentage of the perception of the community. That's why some of the current measures is not really working well right now. And the next one, we want to know also the current experience about the community itself. How could they manage to do it? How could they cope up with the flood? And as you might see here, most of them could not really cope up with flood and drought. And also for the worrying, most of them is really worried about the safety of their health, asset, and economic condition. And then the last one of the public risk perception is the capability. As you might see here, in dealing with both flood and drought, less than 8% of the respondents have a specifically reserved fund to cope with the flood and drought risk. That's why the current uh, the current measure is not really working well because none of them is really have high risk perception enough to know about the drought and flood. And the next one I would say about the public acceptance is 90% of the respondents have been accepted the flood measures in Bandung City, and also the draft is really high. The acceptance rate is really high. However, the awareness of the community about the flood measures, flood mitigation program and drought mitigation program is really high. That's that's why it's contradicted each other, and this is one of the biggest challenges that need to be more focused on by the government about the awareness of the current flood mitigation and drought mitigation program in Bandung City. And this is like the synthesis of what we've been conducting before. As you may see here, according to the survey, affected communities could assess the risk. However, most of them is really most of the flood risk perception is lower than the public draft risk perception. That's why the current flood flood mitigation program is not really working well in Bandung City. And as you make and
Your
I
time
must say
is
here,
1 minute more, Mr.
okay, thank you so much. Maybe I will go to the last slide of my presentation. I will say that the affected community in Bandung City has the potential to be more involved in the flood and drought mitigation program. As you might know, if the community is more involved in the mitigation program, the successfulness of the program it might be higher, and also the spreading of cost of risk reduction measure itself will be more risk free. And I would say the CBDRM is one of the approach that cannot be implemented well in Bandung City. And currently, as a resilience development initiative, we have research about the CBDRM and implement CBDRM and planning in Bandung City. And this is my last slide, and I will say thank you for the opportunity and good afternoon.
Thank you, Mr. Danang, for your presentation. Next, we continue the number 15. The title is Modeling of Volcano Lava Fault Structure Using the Gravity Anomaly Data. The author will be Mr. Budi Legowo, Ms. Rahmi, Mr. Heri, and Mr. Budi Purnama, and Mr. Wiwit. The time is yours.
Thank you, Mr. Seno. Let me start. Good evening, everyone, and welcome to my presentation. First of all, let me thank you all for coming here today. Let me briefly introduce myself. My name is Rahmi Naila, and I'm delighted to be here today to present to you about modeling of volcano lava fault structure using gravity anomaly. Let me begin by explaining background and purpose of this study. Lawu is a volcano located between the provinces of Central Java and East Java. The geological structure of Mount Lawu can be seen from the regional geological map in the form of faults trending west-east and northwest to the southeast. Fault identification can be done by using the gravity method, a method used to measure the density of rocks in the earth. This method is used to identify rock lithology and subsurface structure based on variations in Earth's gravity caused by variation in rock density. This study uses GGM plus 2013 data with the modeling slices adjusted to the cross-section on the geological map. This study focuses on identifying the distribution of gravity anomalies and identifying the fault types in the area of Mount Lawu. The data obtained from the website is a free air anomaly, which is processed to produce a simple Bogey anomaly, then corrected again through terrain correction with the help of DEM or digital elevation model to determine the elevation value of each data point. The result is a complete Bogey anomaly. The spectrum analysis process was carried out to determine the window length used to separate regional anomalies from residuals using a moving average filter. To perform spectrum analysis, it It is necessary to input distance with gravity anomaly resulting from slicing on a complete Bogey anomaly map to be further processed with fast Fourier transform. 5 paths were used on a complete Bogey anomaly map. Spectrum analysis was performed for each path and resulted in the estimated depth of regional and residual anomalies as shown in the table 1. The average window length is rounded to 33, was used to separate regional and residual anomalies using a moving average filter. A regional anomaly map and a residual anomaly map are generated as shown in figure 4. Regional anomalies is deep anomalies that source comes from the inner earth, such as Earth's crust. The characteristic of this anomaly has a low frequency. In contrast, the residual anomaly is shallow anomaly, characterized by high frequency. Comparing to the result of two maps, the residual anomaly exhibited more complex pattern because it describes an anomaly pattern with a shorter wavelength. This is the first result of forward modeling line AB. AB line crosses from the northwest to the southeast of the research area. The subsurface structure of AB line is modeled of several layers of rock. The northwest area of the research site is Lawu volcanic rock with a density of 2.25 gram per cubic centimeter, which is composed of tuff and breccia with lava insertion. The next layer is Condro di Muka lava with a density of 2.9 gram per cubic centimeter, which is bounded by two faults, namely Sido Ramping Lawu fault and the Chamorro Sewu fault. The Sido Ramping Lawu fault limits this lava which flows to the northwest, while the Chamorro Sewu fault limits the lava that flows to the south. Next is Sido Ramping lava. The Sido Ramping lava has density 2.48 gram per cubic centimeter, which composed andesite. And the last layer is Jobo Larangan breccia. This is the second model of CD line. The result of CD line displayed in figure 6. The CD line crosses from the southwest to the northeast of the research area and crosses one fault, namely Chamorro Sewu fault. The first layer in this line is Condro di Muka lava with a density of 2.94 gram per cubic centimeter. And then the second layer is Sido Ramping lava with density 2.48 gram per cubic centimeter. And the next layer is Lawu volcanic rock with density of 2.25 gram per cubic centimeter. And the next is Jobo Larangan breccia, and then the last is Jobo Larangan tuff. This is the last model of forward modeling DE line. The result of DE line displayed in figure 7. The DE trajectory crosses from the southeast of the center of the research area to the north. On the DE trajectory, it doesn't pass through any fault. The first layer is Lahar Lawu with a density of 2.94 gram per cubic centimeters. The second layer is Lawu volcano rock, which consists of tuff breccia with andesitic lava insertion, which has 2.22 gram per cubic centimeter. And the last layer is Jobo Larangan tuff with a density of 2.35 gram per cubic centimeters. In conclusion, let me sum up my main points. The rock densities of 2.25 and 2.52 gram per cubic centimeters were obtained, consisting of tuff and breccia with lava insertion, which were widely distributed in the center of the research area. Then rocks with density of 2.48 gram per cubic centimeter, which is andesite lava distributed along the southwest direction of the research area near the Chamorro Sewu fault. And then rocks with density of 2.35 gram per cubic centimeter in the form of tuff and pumice scattered in the southeast of the research site near the Chamorro Sewu fault. And then the modeling identifies two faults, namely Sido Ramping Lawu fault and the Chamorro Sewu fault. The Sido Ramping Lawu fault is a normal fault that extends across the center of the study area, has a north-south direction, while the Chamorro Sewu fault is a normal fault in the south of the study area and has a west-east direction. That That conclusion brings me to the end of my presentation. Thank you for listening. Does anyone have any question or comment?
Okay, thank you, Miss Rahmi. The discussion will be until the session for plenary. Okay, the next is number 24. Number 24 is talk about analysis of slip surface by using a geoelectrical array of Wonorejo Karanganyar Regency as mitigation of landslide disaster. And the author, Mr. Budi Legowo, Mr. Surya Kusuma, and Miss Alfitra Adam Primas Tawan. For the author, the time is yours.
Here my first, sir.
Okay, Mr. Adam. Mr.
Komentar
Adam,
atau
sorry. Mr. Adam,
jadi kakek yang terdampak
Mr.
langsung ketika bencana terjadi.
Mr. Adam, silakan.
Oleh karena
Oke.
itu komunitas itu
Mr.
menjadi
Danang, can you mute your Zoom? Okay. Mr. Adam.
Okay, can you hear my voice, sir?
Yes.
Okay.
Yes, Mr. Adam.
Great. Oke, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, guys.
Warahmatullahi wabarakatuh.
So, let me presenting my result study of analysis slip surface by using the electrical array at Wonorejo Karanganyar Regency as mitigation of landslide disaster. I want to say thank you for participating and joining this conference, and give me a permission to present this result. And this is the outline of my presentation. There are introduction, theory, method, and result and discussion. So there are several things behind this research. There have been 300 cases of landslides in Karanganyar Regency in the last 5 years. According to RPJP Kabupaten Karanganyar, more than 60% of Karanganyar, of the land in Karanganyar is a prone zone of landslide. And Jatiyoso is one of them because it has a hilly topography and high rainfall intensity. So the latest news about the landslide reported by salpost.com, there was landslides struck into villages in Jatiyoso district, which is Beruk village and Wonorejo village, Karanganyar Regency on 14 April 2021, with 7 houses affected by the landslide. So for me, this research is necessary to do in order to provide some information and improve understanding of landslide disasters. And this is the research area conducted in Wonorejo village, Jatiyoso district, Karanganyar Regency, with three line with this setup, with 200 meters length of each line. And this is the theory. Geoelectrical method is a geophysical method which studies the properties of electric currents that occur inside the earth. And this is the equation for determine the apparent resistivity value, while this is the equation of geometric factor by Wiener-Schlumberger configuration. So basically, Wiener-Schlumberger is a combination of Wiener array and Schlumberger array. So this is a great choice to investigating the slip surface because it has lateral and vertical datum point distribution, and great to either for mapping or sounding data acquisition. And this is table of resistivity value as a reference from Telford. And this is the landslide disaster. Landslide is a displacement of slope-forming components such as rock, sediment, and debris that move down and unearth the slope. There are 2 types of landslide in this case, which is translational landslide. Translational landslide occurs due to the movement of rock masses contained in a flat slip surface. Then the second one is rotational landslide. This landslide occurs because there is a movement of rock masses on a concave slip surface or basin slip surface. And this is the equipment we use. There are a full set of OYOMAC EL resistivity include 4 electrodes, hammers, cables, and other supporting tools like GPS, AKI, stationary. and emergency tools. This is the documentation of data acquisitions we took. So data acquisition, the data,
Can you share your presentation? You haven't shown your presentation.
excuse me.
Your your presentation, your screen.
Oh, I'm sorry. Can you see the PPT?
Yes.
Okay. So this is the method. Yeah. This is the documentation of data acquisitions we obtained from the site. And this is the inversion result from ResstudentV software we obtained. Yeah, the slip surface is signed by the black line. This is the slip surface. Just the slip surface. In the first line, we found that a slip surface is formed an inclined slip surface is potential to cause a translational landslide. While in the second line, we found the concave and inclined slip surface. The concave one is potential to cause a rotational landslide, and this inclined slip surface is potential to cause the translational landslide. And the third line, we found the inclined slip surface that potential to cause a translational landslide. This slip surface material is a clay layer under the sandy clay. This is the clay layer and this is the sandy clay. This is clay layer and this is sandy clay with medium resistivity, while the clay layer is low resistivity, indicates by blue color with inversion result. So with higher intensity, the this layer, the clay layer has a high saturation of water, but this layer it's not good enough to pass and distributes the water underground. So with higher intensity of rainfall, the water that passed from sandy clay layer will get stuck and accumulate in the clay layer. And this layer, the clay layer will become so slippery, and this layer cannot handle the mass and the volume of the layer above it. So it is possible to causes a movements for sandy clay to move out of the slope and occurs the landslide disaster. And this is the conclusion. We have three lines of the study, and this is the material of the slip surface for each line. And this is the type of slip surface we found. And the last one is a type of landslide that potential to occurs in the study area. So thank you for the attention and good afternoon.
Thank you, Mr. Adam. For the next is number 28, talks about tsunami vulnerability. The author is Miss Fajar, Miss Professor Katarina, and Mr. Gento. For Miss
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
I'm Safira. I feel about my paper with title Tsunami Vulnerability Analysis in Case of Earthquake Analysis 2020 year 2020. Background and purpose. Tanah listrik WTC, which is a research area, is an area that has no direct history either Indian Ocean. This area has a flat topography close up to tsunami disasters. The study purpose to analyze the level of vulnerability of the coastal area of the Tsunami Sea through mappings. Study area, Tsunami Sea, which consists of three tsunami park villages, namely Karamidung and Tagalatulon. The research population 43 land units which are arranged based on the overlay of landforms Finland used in the analysis of the tsunami vulnerability by using scoring, ranking, and overlaying tsunami vulnerability parameters from FICO et al., which consists of slope, elevation, land use, distance from the river, and distance from the shoreline. The level of tsunami vulnerability using the formula can you see in screen. Plus of probability level, very low, low, moderate, high, and very high percent. So next, coastal area of Petongan district has a flat slope of 0 to 2%. Next, land use map. Land use in Petongan district coastal area includes garden settlements, rice paddies, fields, ponds, and forests and vacant land. Next, elevation map. The research location is a lowland with an elevation varying between less than 10 meters and 10 to 25 meters. Next, distance from river map. Parameter of the distance from the river by dividing it into 5 classes. Next, distance from shoreline maps. Parameters of distance from the beach are classified as 5 classes. Then this is a vulnerability level map in Petongan district. There are 3 classes of vulnerability: very high, and moderate. Conclusion: based on overlapping salt maps, elevation maps, land use maps, distance maps from river, and distance maps from coastlines, the results show that the level of tsunami vulnerability on the coastal area of Petongan district are very high. 0.33%, high 50.35%, and moderate 41.32%. Okay, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Ya, Waalaikumsalam warahmatullahi wabarakatuh. Okay, for the next presenter is number 105. Is talk about determining factor of landslide. Is the author is Miss Ahyuni. For Miss Ahyuni, the time is yours.
Thank you, Mr. Seno. Good afternoon, everyone. I am Ahyuni from Padang, Delphi Department. Share screen, please. About determinant factor landslides in 50 kota variant analysis 2015 till 2020. The hazard supermarket for its various susceptibility to disaster. In Maputo Regency, one of the Sumatera province agencies, slide and tornadoes, especially for landslide. Almost all things are prone to this hazard. So we can see the Maputo Regency in the West Sumatra province. This study refers to a method aims to determine the factor of landslide in Maputo using WOE, lack of evidence, because this methods, especially in RTRW, for this time being, methods of determine hazardous area, use the heuristic. In their way to know the hazardous area. There was 140 BPBD historical record and field survey. The data was divided into 40. Evidence, positive W and W. And then we add W positive negative, that is result the contrast. And then the contrast if greater than 1 is very significant when the value is approximately 2. And then the calculation of the area under curve. The area under curve value to the factors prediction of landslide 0.6 to 0.7 to 0.8 as a medium or reasonable model. Till 0.9 is a good model, and above 0.9 is very good model. We use the data, the analysis, soil from Badan Balai Besar Pengolahan Balai Besar Sumber Daya Lahan Geological Map (MKG) and BPBD Historical Survey, and then we overlay bank of evidence. We count area under curve, and then we know the significant factors controlling landslides. Thus, there are 8 variables. The area under curve value. Geology 0.8, landform 0.72, then 0.68, elevation 0.65, and height 0.63, slope 0.63, landfall intensity 0.62, and 0.62. And there are parameters for controlling landslide, that is soil type, curvature, and speckle slope. It is the maps of significant parameters. Of area, that is geological factor. Ecology types form as the most significant factor to predict landslide based on positive W and C, and greater than 1 consists of conglomerate and lithological characteristics provide a condition of a landslide. Unconsolidated material form a sliding bank. Hollow texture which can pass water easily and can increase the rate of landslide. Factor, elevation factor, density vegetation cleanness, slope factor, factor. to measure the validity of parameter model and data accuracy, the test was carried out using 59 or 47% and slide point that had been recorded but were not analysis process. It is often area underscore 87. This validity test shows that the parameter model and inventory database are considered. This is the area under curve. Okay. Conclusion, there are 8 out of 11 that can use predictive slide with area under curve values greater than 0.7. Based on significant slide in the region, when slide agency can be derived. In the next step, we can compare heuristics methods analysis. Thank you.
Okay, thank you, Mrs. Ayubni. And this time for discussion. If you have any question, you can write in the chat or you can raise hand. And in the chat, there is 2 questions. The first from Mr. Shah is for Mr. Danang. The question is, what is the form of the mitigation program carried out by the people in the city of Bandung in dealing with the flood and drought? Maybe we can adopt it in our area. And the question number 2 is for Mrs. Rahmi. Is Sam from Mr. Shah is what the potential disaster that may occur based on fault structure modeling. For Mr. Danang and Mr. Rahmi, you can answer this question. For the other, you can write in the chat or raise hand. Mr.
Okay.
Danang?
Yeah.
Silakan.
Thank you. Maybe I will answer the question. What is the form of the mitigation program carried out by the people in the Bandung city and to dealing with flood and drought? Actually, I've been presented before. One of the the mitigation measures that have been implemented there is the retention ponds. But actually, the retention pond is mostly focused on the flood mitigation, not really on the drought mitigation. And most of the retention ponds in Bandung City is not really that big, and it's not really have an impact in Bandung City flood mitigation, flood problem. So I would say one of the biggest, one of the most impactful mitigation program of flood in Bandung City is, it might be retention ponds, but most mainstream mitigation program is also water basement, or a water basement program, or you might know tol air in Bandung City. But it's not really going well right now. And currently in Bandung City, the authorities more focused on the normalization of river or normalisasi sungai, yang which also have been mainstream in a lot of Indonesian countries, Indonesian cities. And for the drought mitigation program, one of the program that has been mainstream enough in Bandung City is the drum course. But the drum course is not really sustained for the program right now in Bandung City. And currently, one of the mainstream program in Bandung City for the drought mitigation is biopores. So maybe that's my answer. Thank you.
Okay, thank you, Mr. Danang. Mr. Shah, do you have comment or another?
Okay, thank you, Mr. Danang. I clearly your answer. Thank you.
Okay, thank you, Mr. Shahriza. And for second, Miss Rahmi, can you answer the question from
Thank you for
Mr.
the
Shah?
question. What are the potential disasters that may occur based on fault structure modeling? The fault is an area that is prone to dislocation, which can cause earthquakes. So I think knowing the existence of fault early can avoid the bigger effects from the earthquakes. And the other is the landslide, I think, can occur that potential disaster by knowing the location of the fault. Thank you.
Thank you. There is any comment, Mr. Shahrizal?
Okay, thank you, Mrs. Rahmi. Thank you, Pak Seno.
Okay. Okay, thank you. Is there any question? Or do you can raise hand directly? Okay, if not question, the time is break for 5 minutes. Is okay continue or we break 5 minutes? The presenter, we will continue it or we will break for 5 minutes. Okay, it's okay for continue, not break 5 minutes. Oh, okay, it's okay. Thank you, Mr. Nanang and the others. Okay, we will continue. We will continue the presenter. Is the presenter session 2 is number 124 is me is sorry is talking about disaster management. Okay. Disaster management effort in wetland and coastal area to cross-sectoral collaboration, case study in Bukit Batu District, Bengkalis Regency, Riau Province, Kecamatan Buah Batu atau Kabupaten Bengkalis, Provinsi Riau. The peatland often become a problem. Land and forest fires often occurs during the dry season and the flood during the rainy season. Many people living on peatlands don't understand the condition of the land they live in. On the coastal side, there is also have abrasion disaster. In the last 20 years, it has abrasion of approximately 115 meters. Disaster management on the peatland and the coast needs collaboration. Cross-sectoral collaboration are starting to show the result. And the method in this research was conducted using the qualitative methods to produce descriptive data from the research object. Data was collected through participation, observation, and the focus group discussion. Then the sample is carried out by purposing sampling on the group involved in disaster management. And the result, in disaster in peat area and coastal area, there are some kind of disaster in Bukit Batu district in Bengkalis city. And the cross-sectoral participation in disaster management, cross-sectoral collaboration between the community government, and the private sector has their respective roles in the disaster management. And for the disaster, the first is abrasion in the coastal area. The abrasion that hit Pangkalan Jambi village has eroded the land area by approximately 150 meters in the last 20 years. Abrasion is also getting worse with damage to mangrove due to the illegal logging, thus making abrasion faster. People still use mangrove wood for the charcoal and trochok or the foundation for houses. So many mangroves are being cut down illegally. And the second, the disaster is the land and forest fire. Has and the land forest fire, the problem is the peatland area is the has disaster due to land and forest fires. Land and forest fire are also a regular occurrence every year. Land and forest fire occurs due to the several factors, natural factor and non-natural factor like irresponsible people. The community has not been educated much about the potential and the problem is the peatlands. They are not fully aware of how to manage peatland properly and correctly. And the second is the and the third is the land subsidence. Land subsidence is one of the most common disaster in the pet area, but many not aware of it. This because many people think the disaster of the peatland are just matter of the land and forest fire. In the Kampung Jawa, there has decreased 7 until 35 in 2013 until 2021. And the cross-sectoral participation in disaster management is there is community, government, and private sector. In community, in the Bukit Batu sub-district, there are several community groups take part in the handling land and forest fire and abrasion, including masyarakat peduli api, kelompok masyarakat peduli api in the fire community, and kelompok pengawas mangrove, farmer, and fishermen group around the location. And for the government, the role of the government in the handling land and forest fire and abrasion in Bukit Batu district can be seen from the active role of the village and district government, which are very attractive in carrying out activity in disaster management. And luckily in the Bukit Batu and also in Jambi region, in Jambi, there are private sector, there's more private sector. One of them is Pertamina. The role of the private sector is handling land and forest fires. And the abrasion in Bukit Batu district is also very crucial for the corporation social responsible program by PT Pertamina RU2 Sungai Pakning is the one that is engaged in disaster management in Bukit Batu district. And the conclusion, the success in the handling land and the forest fire is due to good cross-sectoral collaboration from the community government to the private sector. Each of this element has a role and function of its. The impact is that in the last few years, the Bukit Batu district has been free from severe fire or zero fires. And the absorption of disaster, especially in Pangkalan Jambi village, has stopped. Thank you for your attention. And for next, for number 36, is about LoRa-based Internet of Thinking sensor by Nana Maulana, Mr. Nana Maulana Yosef. Mr. Nana Maulana, the time is yours.
Thank you, Mr. Kuseno. May I share my screen?
Sure.
Okay, I will present our article which has titled LoRa-based Internet of Things sensor node for real-time flood early warning system. We all know that early warning systems are important factor on disaster mitigation and management. It can determine the life and death situation and how big the effect caused by the disaster. One of technology used on early warning system is Internet of Things, especially using LoRa technology. LoRa is different from other technologies such as GSM or LTE, Wi-Fi, and Bluetooth, and especially on the coverage area and the power, because it has low power, so then it's more convenient in using battery and solar panel as power source. On the other hand, flood early warning system need real-time data, especially for flood prediction. So with real-time data, the incoming flood can be predicted more accurately. We try to build an early warning system using LoRa technology, which can transmit real-time data from sensors to help predict the incoming flood based on change of water and the speed of water flow. In this paper, we focus on construction of LoRa nodes. The nodes is in this particular area. This is the nodes. It consists of sensors and LoRa transmitter. And the sensor are ultrasonic sensor for measuring water level and water flow for measuring the speed of flow of water. Beside the nodes, there are gateways to convert the data from the LoRa nodes to the IP base, so they can send to internet. And in internet, we have a cloud server on the Things networks and database on Google Firebase, so we can collect the data and visualize as we may. For the experiment, we test the accuracy of sensor using in laboratory environment, using water flow and using ultrasonic sensor. This is the transmitter. And the result is the ultrasonic sensor accuracy on the lab is 97%, and the water flow sensor is 91%. Besides that, we test the latency by calculating the time between the data read by the sensor and the data sent to the database. If the latency is near zero, we can conclude that the data is sent on a real time. If there is a delay, usually in a millisecond fraction. The conclusion for this experiment is we can use the nodes for early warning system to monitor the water levels and the water flow rates. The data can be classified as zero data latency, or we call it real-time data. Thank you for your attention. That is our paper. Thank you for Mr. Seno. I'll back the line to you.
Thank you, Mr. Nanang, for your presentation. And we will continue for the number 54 is about impact of socialization. The author is Mr. Ketut. Mr. Ketut, the time is yours. Or Miss Dian, Miss Sukma, or Miss Rindawati. Mr. Ketut. Okay. Okay, Mr. Ketut. Wait a minute. Maybe we will continue. Mr. Ketut, we will wait you. Okay, maybe you will pass after number 130. We will continue number 60 is for Miss Enoch, Mr. Rizky, and Mr. Hendro. Mr. Enoch, Miss Enoch. Oh yeah, Mr. Rizky, the time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
My research about socioeconomic influence on condition, the level of community preparedness in the face of landslide disaster in Sukanagara district of Cianjur Regency. Indonesia is a country with a very high disaster potential. Indonesia disaster trend from year to year is increasing. Cianjur Regency is recorded based on disaster risk index occupying the top district for disaster value levels. Sukanagara district is one of the sub-district in Cianjur Regency that is classified as one of sub-districts that have high landslide disaster vulnerability. In the period 2010 until 2020, there have been at least 7 disasters that caused casualties and losses for the community. Here are the results of mapping the level of landslide vulnerability in Sukanagara subdistrict. Based on the result of the mapping, Sukanagara district belong to an area that has a low to high level insecurity. This means that the entire area include landslide prone zones. And this research has been carried out in Sukanagara subdistrict. Sukanagara subdistrict is one of the sub-district in Cianjur Regency, has an area 174 kilometer and with a percentage 4.8% of the area of Cianjur Regency. Located in the southern region of Cianjur Regency, Sukanagara district is a sub-district that connects between the northern and the southern region of Cianjur. And in Sukanagara district, sub-district is divided into uh, 10 village, namely Sukanagara, Gunung Sari, Sukakarya, Sukarame, Sukalaksana, Sukamekar, Sukajembar, Sindang Sari, Jayagiri, and Ciguha. For more details, you can see it on the map. The flow of research that has been carried out can be seen in the following flow. The research variable, the independent variable in the study were education level, age, employment status and income, and place condition. While the dependent variable is the preparedness of the community. The population in this study is the community of Sukanagara district of Cianjur Regency. The selection of the sample using the technique probably random sampling cluster sampling with the level of disaster vulnerability of each village is another consideration. For more details, see the following table. Data from research using SPSS application can be seen into two tables on the screen. In the t-test variable of significant value less than 0.5 in educational variable, while the variable of age, employment and income and condition and conditional of residence do not reach significant degrees. As for the test, the simultan variable socioeconomic condition reach a significant degree can be seen in the table on the screen. Okay. Based on the result of statistic tests, several conclusions can be drawn to the research hypothesis among others. Hypothesis 1 is accepted, meaning that there is influence between the level of community education and level of community preparedness in the face of landslide disaster in Sukanagara of Cianjur Regency. Hypothesis 2 rejected. Hypothesis 3 rejected. Hypothesis 4 rejected. The conclusion is to able to improve the preparedness of the government community and other related institutions can improve the level of public education, both from the level of community education and in terms of quality of education, because society is the main actor who feel and experience disaster, so that losses due to disaster can be minimized. Thank you.
Thank you, Mr. Rizky. And next, we will continue with the number 130 is Mr. Wandi or Miss Sri or Miss Shahrizal. Miss Shahrizal, the time is yours. Mr. Wandi, the time is yours. Mr. Wandi, you can present? Mr. Wandi, I can hear you. Sorry, Mr. Wandi, I can hear you. The others is Mr. Wandi. You can hear Mr. Wandi speaking?
Not yet.
Okay.
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 I'm sorry.
Okay, Ms. Shahrizal, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. I would like to introduce
Ms. Shahrizal. The voice is noise. Maybe
yes.
the others can mute.
Team.
Okay. Okay. Go.
Yes. Ada suara, Pak?
Silakan, Mr. Rizal.
Hello.
Hello, Mr. Rizal. Ada. Ya, silakan.
I'm sorry. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. I would like to introduce myself. I'm Wandi Asari from Universitas Negeri Gorontalo. I will present my research on identification of fault-prone areas
based on Geography Information System, GIS, a case study of Buntulia Subdistrict, Pohuatu Regency, Gorontalo Province. Background, Buntulia Subdistrict, a fault-prone area for disaster often occurred in sphere village. When the intersite of rain is high, community use land for agricultural, plantation, mining. Buntulia Subdistrict, placed by two big rivers, namely the Taluduyunu rivers and the Butudulanga rivers. Identification of problem, flood occurred in 3 villages in Buntulia Subdistrict during the rain season. Lack of public awareness of excessive land use in the study area. Information of the problem based on the background problem identification of a problem can be formulated how to map fault prone area using a spatial approach in Buntulia Subdistrict Pohuatu Regency. Next, research location. This research way occurred out in Buntulia Subdistrict Pohuatu Regency, Gorontalo Province. The research area has an area of 434.8 square kilometer. Research area include Desa Buntulia Tengah, Desa Buntulia Utara, Desa Hulawa, Desa Karya Indah, Desa Sipatana, Desa Taludunu, and Desa Taludunu Utara. Data. Primary that a public perception concerning fault, community interview about fault issues, a community interview about fault, a characteristic, secondary data. That slope map area used to classify slope, in the study area, rainfall maps. Rain map is used to classify rainfall in the study area. Land use map area used to classify land utilization in the study area. Okay. Next. Data analysis. Scoring and weight. The distribution of fault-prone area. Weight do the scoring of each parameter applied in this study include slope, rainfall, and land use. Spatial analysis is a set of techniques for managing geography information system GIS data. Total score, all parameters were overlaid using GIS software continue with summing up each score to generate the total score of all parameters. Class interval determination, number of class used in the study, wherefore it's show the level of vulnerability. Slope map of Buntulia District. The slope map is divided in 5 slashes, namely 45% step, 25 to 45% step, 15 to 25% at her step, 18 to 15 sloping, 0 to 8%. Buntulia District slope table. The table shows that the very vulnerable class has an area of 21,163 hectares, 48.75% with a slope of more than 45%. So there is a high potential of flooding when there is very high rainfall. Next, Buntulia District rain maps the annual rainfall in the study area is classified into 4 classes in rainfall. Buntulia District rainfall table. Rainfall in the sub-district of Buntulia can be classified as range in the range of 21 to 2,500 millimeter years. I can be categories modern, humid, with an area of 10.02%. When it's rain in very high amounts, it can cause flooding. Next, Buntulia District land use map. The land use of Buntulia sub-district is classified in 9 classes, namely forest, plantation, supplement, ridge, flight, shrub, mining area, barlands, freelands, sand. Buntulia District land use table. The table shows that the search area land use was diminished by force that of 90.99% area. Table for disaster hazard for fold in Buntulia District. This table shows that very vulnerable class were identified in 3 villages in namely Desa Hulawa, Desa Karya Indah, Desa Talwidunu Utara. Fault hazard level maps. The result of the analysis obtained for categories namely for vulnerably what, somewhat, vulnerably, and not vulnerably. Okay, next conclusion. Level of fault vulnerability in the Buntulia sub-district was classified in 4 categories. Very vulnerably has an area of 1,275 hectares or 2.93%, which spread in Desa Hulawa, Desa Karya Indah, and Desa Talwidunu Utara. Vulnerably was an area of 4,493 hectares or 10.35%, which extend in Al-Village in Buntulia sub-district. Someone vulnerably with an area of 21,406 hectares or 49.31%. Some non-vulnerably with an area of 16,200 hectares or 57.37%. The results show that the area affected by that fall disaster were Desa Hulawa, Desa Karya Indah, and Desa Talwidunu Utara. Thank you.
Okay, thank you, Ms. Tarwandi. And the last for number 54, Ms. Ketut, Mr. Ketut, Ms. Dian, Ms. Sukma, Ms. Rindawati. The last call. For number 54, Mr. Ketut, Miss Dian, Miss Sukma, and Miss Rindawati, you can present now. If you are not allowed, okay. Okay, we are the okay. If not, we will continue to discussion. There is two question for the session 2. The first question for Mr. Wahyu and team, how to make cross-sectoral collaboration effective in disaster management in coastal area, and what should be the role of the community in this collaboration. And the second question for Mr. Rizky is, how do community divide their income between meeting the necessities of life and the budget for disaster preparedness? Is from Ms. Shahrizal. And for first question, I will try to answer. The key to make the effectiveness of the cross-sectoral collaboration is the communication and transparent. Luckily, CRR Pertamina Sungai Pakning, CRR RU2 Pertamina Sungai Pakning is in know about the culture of the Riau people, especially Bukit Batu people, is there is in every evening, the men always drink coffee in coffee shop or warung kopi, and in this coffee shop or in this warung kopi, there is no level. The old people, the level is same. So the CSR Pertamina is very likely to know about this, and we always communicate informally with the people, and we know the needs, what the people needs, what the government needs, and what in this communicate we can get idea, and after we get idea we can communicate, we can speak in the formal group, like focus group discussion between Pertamina and government and also the communities. So every sectoral always communicate and always transparent what they need, what they serve, what they provide. In the Pertamina, if we give the like help for the people, we give, I just have this and I want to back disaster management, and after that, the collaboration between three government, communities, and also the CSR Pertamina, maybe it is the private sector, is very effective, is very efficient. So what should be the role of the community in this collaboration is not only community, but the government and also the private sector is also being include the environment. We part of the nature. If nature destroy, we will destroy too. So this is my answer. Is there any comment, Mr. Rizal?
Okay, thank you, Mr. Seno, for your answer.
Sorry. It's okay? There's any comment? If not, Mr. Syahrizal, sorry.
Okay, next.
Oh, next. Okay, thank you. For the next, for the Miss Rizky Arliandi. You can answer the Miss Syahrizal question.
Okay, thank you, Miss Rizal, for your question. Uh, Honestly, until now, the society that is the object of my research has not sought out income fairly or preparedness. So, I think your question can be an input to socialization related to the distribution of community spending on areas. I think.
Any other comment,
Thank
Miss
you.
Syahrizal?
Okay, Mr. Rizky, because the role of community is very important for disaster preparedness because one
Sorry, your
requirement
sound so
one
big.
requirement for disaster preparedness is a budget for disaster.
Sorry, Mister. I can hear you.
Okay, I think budget for disaster, yeah, is very important. Uh, Maybe yeah, Mr. Seno, please. Yeah. Hello,
Yeah. Halo.
Mr. Rizky. Your answer, please. Because I think the preparedness.
Sorry.
Okay, next.
Sorry. Okay, next me. Okay. Terima kasih. Okay, thank you. Sorry for the inconvenience, Mr. Rizal. Okay, thank you for Mr. Rizky. And we will continue to session 3. In the session 3, there is 5 presenter, and the first presenter is the number 73. Is talk about the use of drone to determine potential location of reservoir. And the author is Mr. Cahyadi, Mr. Ode Sofyan, Mr. Fauzi Ramadan, Mr. Mushab, Miss Octavia, Mr. Rio, and Mr. Zainul. For the author, the time is yours. The authors. Okay, Mr. Zainul, the time is yours.
Okay, hello everybody. Good afternoon. I would like to thank to committee of the ICoDMC International Conference of Disaster Management and Climate Change for giving us the opportunity to our research. The title of our research is use of drones to determine potential location of Ralph Reservoir to anticipate water crisis in Woningali village. I am General Abidin as one of the researchers in this study who will present to the result of our research. Okay. This research is taken place in Woningali village, Jonggol district, Bogor Regency, and West Java. The location experienced a drought due to climatic conditions. This had an impact on the water demand crisis in Woningali village. We know that in this picture, we can see the real condition of Woningali, who does not have water during the dry season. The people in Woningali village has problem about water. It makes people depend on river and water supply sold by trade to fulfill their domestic needs. Okay, this is the real condition in Woningali village. Okay, next, the methods is the research method used in this spatial multi-criteria evaluation or SMCE. Method and the overlay based on the research designed to identify the best location for the construction of the reservoir in Woningali village. SMCE is used to determine the height of the 6-parameter factors of the best location if the reservoir based on the value of the SMCE comparison standard in table 1. The outline of the research design of this study is shown in flowcharts. Okay. Based on the result of data processing for each parameter can be seen in figure 4. The results, the number of aerial photos is used in 6,609 units within area of 444.506 hectare Woningali village. The process taking aerial photos with drones use a flying height of 160 meters above sea level with 80% overlap and get 21.9 centimeter per pixel of GSD resolution. In the previous studies, the determination of the location of the reservoir utilized the use of UAV or unmanned aerial vehicle, which results in reconstruction in 3D. The results of this study indicate that the use of UAV in determining the location of reservoir has high accuracy. Okay. Based on the result of data processing for each parameter can be seen in figure 4. Okay. Number 1 or A is rainfall. Can be seen that the average amount of rainfall in Woningali village varies from a minimum rainfall until maximum annual total. And number 2 is dryness density. The dryness density at the research site, which is included in the highest category, is in area 2 and area 3 of Woningali village. And number 3 or C is land cover. Woningali village has various and land covers, rice fields, settlements, water bodies, and undeveloped land. Based on the picture, it is known that almost 80% of the area in Woningali village is used of rice field. And number 4 is elevation. The height of elevation, the height of Woningali village ranges from 16 to 140 meters above sea level. You can see on figure A. Based on the picture D, it can be seen that the area that is classified as higher land is in area 2 with maximum height of 140 meters above sea level. Number 5 is slope. The higher the slope, the faster the surface runoff, and vice versa. The slope is directly proportional to the speed of the water flowing. Most of the area in Woningali village is classified as sloping. And number 6 is geology. Geology, there are 5 geological formations available at the study site, namely alluvium, Chihuahua Formation, floodplain deposit, older alluvium, and sandstone. Most Wuningali have older alluvium geological structure which have a good shear strength, low comparability, and are good for construction materials. Okay. Based on the result of the analysis, there are 3 locations that can be considered for the construction of reservoir based on spatial analysis. The first potential site of reservoir is in area of the 423 meters. The second one potential site of reservoir is 1,450 meters. The last one potential site of reservoir in area 3, land area of 1,191 meters of the study area. The third location gets its water supply from the Chihuahua River. The third location has many parameters. The parameter consists of the form of the slope, drainage, density, and land use. Okay. And next. Okay. This slide shows an exciting picture of 3 potential reservoir location. Image 1 is shows location 1, and image 2 shows location 2, and image 3 shows location 3. And the conclusion, in this study, the analyzed process utilizes GIS using drone data to identify potential location for the construction of a reservoir in Wuningali village. This study used 6 thematic layers as consideration for spatial analysis, including rainfall, drainage density, land cover, geology, slope, and topography. The slope factor is the most influential factor in spatial analysis. With a weight of 20%, based on this parameter, it can be seen that the area of the reservoir, which is the very suitable category. Then, based on the analyze using the SMCE method, is it known that there are 3 locations that have the potential to build a reservoir in Wuningali village. These 3 potential can be a reference for the Bogor Regency government to overcome the water crisis in Wuningali village by building a small dam or reservoir. And last one is the result of this study can then be used as material for consideration by the Bogor Regency government to be able to follow up on priority location for the development on village reservoirs in terms of level of village water availability in meeting the community domestic water needs. Okay, that's all my presentation. Thank you for your attention and good afternoon.
Okay, thank you, Mr. Zaino. And we will continue to number 81 is talks about the analysis of spread COVID-19. The author is Miss Risa Jayanti, Mrs. Pipit, and Mrs. Rita. Miss Risa, the time is yours. Okay. Okay, Miss Risa, we will wait you until the number 64. Okay, we will next person for the number 88 is talk about the worst case tsunami inundation modeling. The author is Mr. Handy, Mr. Ahmad, and Mr. Taufik. For the author, the time is yours.
Thank you very much. Wait a minute, let me share my screen. Can you see it now?
Okay, Mr. Handy. I can see.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, and thank you very much. It's been an honor to be here presenting my paper entitled Worst Case Tsunami Inundation Modeling using High-Resolution UAV or Unmanned Aerial Vehicle Digital Elevation Model in various coastal typologies. Case study in Gunung Kidul coastal area. My name is Hendi Fatur Rahman. I'm from Department of Earth Technology, Vocational College, Universitas Gadjah Mada, on behalf of our team, with my colleague, Mr. Ahmad Sayadi from Department of Environmental Geography, Faculty of Geography, and also Mr. Taufik Heri Purwanto. So on the right of the screen, you can see a figure that showing the number of the population in Indonesia that live in the tsunami-prone areas. And as you can see here, let me use the pointer. As you can see here, Indonesia is on the top with the number of people living in the tsunami-prone areas, and more than 4.35 million people in Sumatra, Java, and Bali as the most populous island live in the prone area of tsunami or exposed to tsunami hazard. And we all know that we are living in the ring of fire zone where earthquake is considered as common events. Everyone is already get used to earthquake events, but the thing that we have to pay attention is the seismic gaps. Here, as you can see in the right figure, there are around 8 seismic gaps that existed in Indonesia. And according to the last research by the Meteorological, Climatological, and Geophysical Agency of Indonesia, these seismic gaps potentially trigger really big megathrust earthquake that could trigger 8.8 scale of earthquake. And as you can see here, those earthquake could also generate a really high tsunami wave alongside the southern coast of Java. And the height of the tsunami is varies from 5 meters to 20 meters as the worst. And some part of southern coast of Java is exposed to 12 to 15 meter of tsunami height. And morphological characteristic of its typologies also play a significant role in tsunami susceptibility. For example, here on the left, you can see the satellite image of some certain place in Aceh. This is Lokna area. This area was completely wiped out by the tsunami in 2004 because the topography is dominated by the flat area. Therefore, from here we can conclude that the topography is play a significant role in terms of tsunami susceptibility. And here, our research or study location is located in Gunung Kidul Regency, especially the southern coast of the Gunung Kidul Regency, because Gunung Kidul has the longest coastline in Yogyakarta. And despite its mostly form of the limestone and also karst landform, but if we have a look closer to some beaches, there are some difference among beaches. For example, here is Trini Beach. The shape of the coast is something like this, with valley that connected each other like this. For example, this is Krakal with very broad bay and also flat terrain. And this is some places also around that mostly dominated by the cliff. And this also, for example, Baron Beach that form a cove that really narrow space. So we propose tsunami inundation modeling and we apply it to a different coastal morphology or coastal typology, and we want to see how it could be impacted by the maximum worst case tsunami scenario. But utilizing the national topographic data is pointless since our area is considered as like only a small area. And for example, here, if we use national topographic data or RBI data that downloaded by the national portal, it could only generate a digital elevation model like this. But when we use UAV data, we can generate really accurate digital elevation model. And this is necessary for hydrological modeling and also disaster modeling, especially tsunami, because we need to have a really good spatial resolution for executing the model. And this is our area. First is in Baron Beach, and second is in Trini Beach, and third is in Odiombo, which has different characteristics. And we use drone deploy for the flight mission. This is the flight mission for its locations. And this is the ground control point measurement, and this is the vehicle or the tools that we use Phantom for. And this is the processing from a point cloud generation to ortho mosaic image and also digital elevation model that we use that we process using ArcGIS of Metasheet. And this is the result. This is the aerial photograph of Baron Beach. The Baron Beach is mostly comprises of land erosion coasts with the accumulation of loose materials such as sand like this, and there are also river mouth or underground river mouth from the Pripin underground river here, as you can see in this figure. And this is the tsunami model, like using the worst scenario 12 meter. Almost the whole area was inundated because it's only a narrow area. And this is the cross section, as you can see here. The valley is covered by, is situated in the middle of the hill, something like this. And the terrain in the hill is the terrain in the valley is really flat, up to 500 meters to the landward. And this is the second location, Trini. The characteristic is a bit different. It's dominated by flat area. The valley that connected each other surrounded by the karst hills, but not as narrow as Baron Beach. And mostly it comprises of marine depositional coast with erosion coast and also a coast that built by organism. And this is the digital elevation model. And this is the tsunami inundation model with the same height scenario, the same run-up scenario. The area that affected by tsunami is much more wider compared to Baron. And as you can see here, more area were affected by the tsunami model. This is the digital elevation model. Actually, this is the slope model. As you can see here, the profile, the terrain profile in this valley is really flat.
The time is 1 minute more, Mr. Hendy.
Okay, thank you. And the coffee maybe to the last. This is Diombo, but Diombo is formed by the volcanic processes. A little bit different with two other beaches, and the topography is dominated by steep hills perpendicular to the Diombo Bay. As you can see here, only a small part of the area were affected by the tsunami wave. Something like this. This is the terrain profile. Yeah, I think that's all, and the conclusion is based on the models. Baron and Trini area is considered highly susceptible to tsunami hazard because of the terrain configuration that mostly comprises of karst valley, but Diombo is a little bit different since the origin is also from the volcanic processes, and the terrain is considered as dominated by hilly landforms, so only small part of the area is affected by the maximum tsunami model. I think that's all from me. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mr. Hendy, for your presentation. Next, for the number 126, the author is Tasa Ayu, Mr. Wahyu, and Miss Aulia. The time is yours. Yeah, Aulia. Yeah, maybe we will be the next for the number 64. is the analysis of social vulnerability index in watershed Bengawan Solo downstream. The author is Suryanto. Mr. Suryanto, Ms. Aulia, Juwita, Mr. Daniel.
Yes.
The time is yours.
Okay, thank you. Wait.
Silahkan, Mr. Aulia. Miss Aulia.
Okay, 5 minutes.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Terdengar ya?
Let me presentation.
Ya, terdengar.
It's about social vulnerability analysis of community in the watershed of Bengawan Solo in the downstream. Climate change is an environmental issue that become discussed in various countries, and the impact of social and economics, such as damage to infrastructure and clean water, electricity. And in Indonesia have three type climates, include seasonal climate, and then hot climate and marine climate. Because climate change, high rainfall can result failure in crop or flooding, and prolonged dry season, which can cause dry for rice fields. And then the natural disasters that often occur in the East Java area in the 2018 period were floods, and Bojonegoro, and then Gresik, Tuban, and Lamongan become a city that relative had more flood. This because of river sedimentation that occur due to soil surface erosion and damage to watershed, which is tidal land. And then on the other hand, climate change in the dry season also cause several disasters that occur in the downstream of Bengawan Solo sub-watershed area, such as drought and water shortage. Cause a lot of loss and material loss, difficult to get clean water and food, and welfare can change natural disaster phenomenon. The community definitely must face social vulnerability in natural disaster, and social vulnerability is an indicator of vulnerability. It is measured based on the social condition of the community. And then social vulnerability is the level of community ability in dealing with disaster that occur in an area. And the our research purpose to know the level of social vulnerability and socio-economic description, and then mapping of comparison of social vulnerability in watershed of Bengawan Solo along Bojonegoro, Tuban, Lamongan, and Gresik. Our methods, we use three methods, and first, socio-economic description, and then social vulnerability index or SOVI, and the last analysis of Geographic Information System or GIS. Okay, and then results. First, we have socio-economic description. Socio-economic description and discuss about regarding to administration and then population and the number of flood case. This table number of flood case in Bojonegoro and Tuban, Lamongan, and Gresik. From all of this, we know at 2014, 2015, and 2016, the flood was occurred in the regency, and the Bojonegoro had a victim until 1 million in 2014. This is the victim higher than another regency, and then social vulnerability index of it. The main component and subcomponent of its region content explain that the highest Sophie score was 7 in Tuban Regency, and then the score of Bojonegoro was 6, Lamongan 4, and the lowest Sophie was Gresik with 1 score. The score result was then included in the vulnerability classification that has been created, and Bojonegoro with score of 6 was included in high level vulnerability. Tuban with score 7 with also include in high level vulnerability, and Lamongan in category moderate level, and Gresik Regency with 1 score was classified as an area with a low level of social vulnerability. And then the last 4 results, we have map of vulnerability SIG. This spatial analysis is needed when of non-spatial analysis and consider insufficient to answer some question, and as well as to find out the location and distribution on disaster problem. And from the map, there's is a relationship between the magnitude of the impact or loss due to disaster and public health phenomena. The condition that cause difference in the level of vulnerability related and to flood in East Java caused by number case, the magnitude of the impact, and population density. And then to conclusion, the calculation using the social vulnerability index SOVI methods explain that the highest level of social vulnerability was Tuban Regency with SOVI score 7, and then Bojonegoro Regency SOVI score 6, Lamongan 4, and the lowest level of social vulnerability was Gresik with score of 4. And based on the socioeconomic component used, Bojonegoro and Tuban Regency had the highest score on socioeconomic component, and the Lamongan and Gresik had same score with a low category. The result of the mapping using the GIS Geographic Information System illustrate that Tuban and Bojonegoro were included in the highest vulnerability category, and Lamongan Regency had a medium vulnerability category, and Gresik Regency has a low vulnerability category. Okay.
Okay, thank you for Miss Aulia presentation. For the Miss Risa and Miss Tasha, we will continue the last session in the session 4. Maybe for this discussion, is there any question for the 3 presenter? The first for Mr. Is there any question? Or if you want to ask, you can raise hand or write in the chat. Okay, maybe there is no question. Okay, we will continue to session 4. The session 4, the first presenter is number 42. For the Miss Rita and Mr. Sofyan, the time is yours. Masih di Mas, masih di ini di mute.
Thank you, Mr. Denong. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Good afternoon. Let me introduce myself. My name is Sofyan Soleh. I'm here to present my research of prediction modeling of residential areas based on disaster hazard map using cellular automata in Gondang Rejo District, Karanganyar Regency. Gondang Rejo is located on the north side of Solo City. Since the construction of the Solo Kartosono toll route since 2013 has changed the characteristic of the region from rural to urban. The construction of the Solo Kartosono toll route quickly changed the face of the Gondang region. This is my schema about my research. First, use a driven factor to exclusion distance until city physical development projection model. Result and discussion. Estimate settlement ground in 2032. Based on the result of calculation that have been carried out in found that one resident of Gudang Rejo district required a residential area of 42 meters per second. The population growth of Gondang Rejo sub-district in 2013 until 2032 was 49,575 people. So that the development of residential land in 2030 until 2032 cover an area of 208,000 to 15 hectares. And this is my driver factor to growth projection. My model is education facilities, health facilities, primary route, toll route, secondary route, industry, and settlement. And this constraint to and growth my projection. And this simulation prediction my settlement in Gudang Rejo Regency. This is a residential growth prediction simulation in Gudang Rejo district. A, Gudang Rejo district 2030 existing, and B, 2032 simulation. And this is look different because primary route refer to factor, and I'm used validation my prediction use land use existing in 2021 simulation, and look like similar but not same, but majorities validation 92.5700 57%. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mr. Sofyan, for your presentation. Maybe next we will continue to number 14. This we will continue to number 57 for Mr. Sultano. Mr. Sultano, the time is yours.
Thank you for the time. My name is Sutarno. I will present my paper with the topic analysis of landform, early warming system, location, and evacuation path for choosing flood disaster risk in Sragen, Central Java, Indonesia. Background and purpose. Cause of flood disaster in Sragen, there are A, heavy rain, B, over water flow from Bengawan Solo River and its tributary in basin or lowland. E, use of border landform and river embankment for agriculture and settlement. The community lack of response to the sound of the early warning system EWS siren at night cause flood to surround the affected area, so make the evacuation of material transportation to the disaster post. The impact of the flood disaster there is loss of life loss, damage, and destruction of agriculture land, settlement, and the environment. B. Damage and disconnection of land transportation infrastructure so that it disrupts social, economic, and environmental activities. Purpose: to analyze the distribution of landform disaster risk flooded along the riverbank in residential area and rice field affected by flooding. To report shelter location and evacuation routes for handling disaster risk reduction. Method: the result of the method grounded research, or direct survey in the field and conducting interview and forum group discussion using prepared questionnaire. Result: Sragen is located geographic between 113 degree 45 minute to 111 degree 10 minutes is longitude and 7 degrees 20 minute to 7 degree 30 minutes south latitude. Rakin G has territorial area of 941 kilometers square. It's divided into the 20 district or 200 each village. From the territory area, Sragen consists of 40,182 hectare, or about 42.68%. There is wetland, and the other 53,973 hectare, or 57% is dryland, whereas disaster location is in the area around Bengawan Solo River and lowland. Based on the map 2009 Sragen Regency drainage map, the flood disaster risk is located on the middle Sragen area around the Bengawan Solo River with its branching river. Like on the 2008 RTRB map below, there are nine EWS installed but found 2 EWS broken as soon as possible to repair. The accuracy of the location of the post, the distance and repair of the evacuation route are very decisive in reducing disaster risk. Based on pre-map of flood disaster year 2018, 2019, 2020, and compare map RTRW 2008 disaster prone is seen It's in the color blue until dark blue that there is a safe is a flood disaster area. This is due to a collapse of river embankment in the lowland and the use of river bank for land agriculture and residential. That is can see in beside sub-district and village. In the year 2018, the number of village 30. And this area 36 36,415. Sidoarjo 8 village, Tanon 8 6 village, Plupo 6 village, 5 village, Rampal 5 village, Masaran 5, Sragen 2 village, Gondang 2 village, and Mondokan 1 village. Another way in 2018, 7 village. And in 2020, uh, 10 village. Conclusion. The biggest flood disaster occurred in 2088 cover 30 village, with an area of 415 hectares. In 2013, there are only 10 villages. Even so, the area of the submerged area is quite high. This is due to the collapse of the river embankment and the use of riverbank for land agriculture. In Sragen, 9 EWS are installed, but 2 EWS are damaged. The accuracy of the selection, location, and evacuation path for reducing flood disaster risk in Sragen. Thank you.
Okay, thank you, Mr. Sultano, for your presentation. And for the next presentation is number 13 is Kusumadia Nurul Handayani. For the Kusumadia, the time is yours.
Mana? Nggak ketemu. Ini.
Okay. For Kusumadia, Kusumaningdia, maaf. Kusumaningdia. Mbak Kusumaningdia. Miss Kusumaningdia. Miss Kusumaningdia. Okay, maybe Miss Kusumaningdia, they will be passed. And next is the number 63 is me. Okay, I will to present my research. Research is talks about the level of disaster literacy of teacher and student in secondary school. Case study in Surakarta City, Indonesia. And in the disaster management, there are three cycles consistent pre-disaster, disaster, and post-disaster. Knowledge of disaster management can raise awareness of the disaster mitigation of the population and include part of the disaster literacy. In disaster mitigation knowledge, one of the be able to distinguish between natural phenomenon before a disaster and the disaster information. This study to describe the disaster literacy level, information level in the teacher and secondary student. And the method I used to theory the model disaster literacy models Brown and also the Doyle theory of information literacy. I will mix the theory and for the line of the making questionnaire, and I will analyze of the survey result using the present test technique, then data will analyze with descriptive methods. And the result for the level disaster literacy in teacher and secondary student and teacher has passed in this basic of this disaster literacy or the level 100% of teacher know and understand evacuation step when the natural disaster occur, ranging from the geological disaster to meteorological disaster. On student, there are only 20% of students who don't know or don't understand about the evacuation during a disaster because of the self step and the panic. Especially in tsunami and the earthquake natural disaster, there are still students who try to save property and are unable to control their fears. And for the functional disaster literacy or the level 2 of teacher and student has passed. As many as 50% teachers and 25% of students immediately evacuated themselves out of the room when the earthquake occurs. Two of the step can be done in condition are felt safe to go out. The same thing that happened to flood evacuation. Only 20% of teacher and 17.5 students were able to remember and the following evacuation procedure correctly. And for the adequate disaster literacy level as part of information literacy, the disaster literacy are communicate and the critical information is low because the ability of the information literacy in knowing the accuracy and completeness of the information on teacher and secondary student is low. Just only 5.5% teachers and 7.8 students confirm the accuracy of the disaster information. The majority of other teacher and other students immediately believe the news which they got. So they immediately evacuated themselves. And the fact, the most teacher and the secondary student are reluctant to seek complete information. They immediately evacuated if they receive disaster news, even if it is a piece of information. Only 5.2% students who want to find the completeness of the information. And the conclusion, teacher and secondary students have good quality in adequate level of disaster literacy, but they have low quality of information literacy. It makes teacher and student cannot tell the differences between natural symptoms before disaster and disaster information. This is what makes the public may easy exposed to hoax news because most Indonesians admit that sometimes they can tell the differences, but sometimes they cannot tell whether the information they receive is hoax or not. Thank you for your attention. And for next number 66, Mr. Wandi, Mr. Sri, and Mr. Shahrizal, the time is yours.
Sudah selesai tadi Pak Seno?
Ya, saya sudah selesai. Sekarang tinggal Mr. Wandi.
Sudah selesai tadi presentasinya.
Oh, kok ada dua ya?
Kayaknya dua.
Oh, tapi sama ya?
Iya, 130 sama 66 kalau nggak salah.
Oh iya. Sorry, Mr. Wandi. Oke, sorry. Okay. Next, the number 100 is for Ahmad Hussein, Mr. Ahmad Hussein and Mr. Samadi for the presentation. For Ahmad Hussein and Mr. Samadi, the time is yours.
Pak Seno, selamat sore.
Bu, maybe number Bu Kusuma?
Yeah.
You are ready
Ready.
to present? Okay.
Yeah, thank you very much, Pak Seno.
Okay,
Yeah.
Bu.
Can I share? Okay.
The time is yours, Bu.
Yes, thank you very much, Pak Seno. Good evening, everybody. It is very pleasure for me to join this conference. And today's I would like to sharing about my research studies, case study in Surakarta. My name is Kusuma Ningdia Nurul Handayani, and I'm from Department of Architecture, Faculty Engineering, Universitas 11 Maret. And today I would like to deliver social design as a strengthening strategy in the revitalizations the sub-communal Mojo Kampung in Surakarta during COVID-19 pandemic. Actually, this project is one part in my subject lectures. Then we are concerned in the Kampung Kota as a type of residential that occupied by a large portion of urban dwellers. And then, as we know, there is a lot of improvement kampung program initiated by government, and one of the program in Surakarta located in neighborhood RW1 Kampung Sub Komunal Risa Mojo Pasar Kliwon. So actually this kampung is a temporary kampung settlement area before they move into the new area in the Kampung Metal Mojo sub-district. And this is very interesting because living the communal housing is not directly has a guarantee of a hygiene environment, particularly when the pandemic COVID-19 happened in 2002. The residents are dealing with the issue of hygiene environment and adjusting from home during the pandemic area. And the beginning 2020 was a non-natural disaster, as we know. The disease outbreak pandemic, the pandemic happening almost all around the world, and including in Solo, we struck with this pandemic, yeah. And then sure, its impact to the kampung, where the people living there.
And this is a case study of social design projects that we have been done with our students, and also engage with the community architecture in Solo. We call it Artcom Solo. So we have the intermediate partners that are really actually doing a lot of projects with the community in Kampung Mojo. And this project was done from 8 months, beginning the first phase of pandemic COVID-19 until the end of the 2020. And today we would like to evaluate what we have been done so far in this project. And therefore, this paper is show how social design project case study that initiated by academicians in URDC Labo architectures with the NGO Arcom Solo become as one strategy as the knowledge diffusion for the inclusive innovation dealing with the disaster mitigations. We investigate the need of resident in the beginning of pandemic, so we not jump going to the project directly. We investigate the resident behaviors, what they really need to observe their domestic space regarding environment by conducting in-depth interview. And this is the interesting one because we use the technology to engage with the community. And also by this we did the project collaboration social design, we call it, to deals or tackles the situation of the pandemic. Therefore, the study aims to develop adaptation model for disaster preparedness that is adapt to the locality of the kampung resident, so that it can be applied as a design strategy in the community during the pandemic through the social design project in the kampung subcommunal Risa Mojo. The method research we done between quantitative and qualitative, and therefore there are three proposed. We would like to identify the need of resident, and second, we identify the factor affecting the social design process going smoothly. And the last one, to identify the network of actors in the case of from social design assembly in a dynamic mode that might be differ on each stage of the process. So then several steps that we have been done during that the project 8 months. We call it, this project is Bangkit Berbarengan. And then we did the field survey, shadowing, interview, FGD with the resident, workshop design with the resident. And the output is we have the advocation poster for the community, and also the modeling design that we execution by the collaboration works, and doing the design product workshop with the local carpenter in Kampung Mojo. So here we are. When the first response coming, we asking them what they really need, and then we do the the donations. We open donation for them because they really needs the daily needs, yeah, like sugar, like rice, and we try to help them. So I think this is a very important beginning, because then we have the connections with the community. And after that, we try to collect all the data and then try to build together what is the local icon in that area, because it's really long in the riverbank of Solo, and Raja Mala is one of the icons. So the icon that coming with the advocation of the COVID, knowledge of COVID sharing. This is we develop together with the community, and it is really adapt and really attach, because the children really like for this cartoon or the icon, yeah. And then we separate all these informations through the WhatsApp. We share with Facebook also, and the social media. And then going to the community in Kampung Mojo. Another things, strategies that we tackle is also the public communal. We call it padasan, because they at the time for the communal padasan, it is not served in this area, yeah. So therefore the student of architecture try to do the exploration sketch, and then we did the focus group discussion. Surely this is we just limited with only several residents, and then the students, not all the students coming, and we dealing with the hybrids, daring and luring, yeah. And then we try to also learn from the local carpenter here, and try to develop several padasan, and then we put in the environment. So what we need from this project along the 1 years, the leadership is important from the respondent, that we take the data from the observation, shadowing, and then do the focus group discussion. Community initiative and collaborator network, how initiatives are generated in the community. We try to evaluate for almost 1 month with the respondents from the community itself, Ibu-Ibu PKK, and also the intermediate partner of our project, Arkom Solo. We did the observation. And then sustainable kampung program, how the padasan it is up now is still sustained and they still use it, meaning they need these things to be settled in this environment. Therefore, the factor effective that influence the social design process, we try to do the evaluation through the leadership, community initiative, and sustainable social design. We really can find that the community initiative, it is really important to have the creative idea. And sure, it is will be very depends going to the leaders, yeah. And then we try to collect the network actor in each stage design process because it's various and diversity. And we found that the stage 3 and stage 4 is really important. When we did the product design, actual selected project, and project implementation, that's more actors involved in this project. Expert local carpenter, it is very important because we are, as a student from an architect, we also learn something out of the context. I mean, we really have the experience in the field side, learns the expert local carpenter, because in the Kampung Mojo is very well known with the iron used. So this is a kampung where we call it in Javanese Kampung Rosok, but then the people or community there is really experts for the ketukangan, and we learn extensive ketukangan here. So this is more bigger actor and bigger knowledge we sharing together. So therefore, the conclusions is during from this project, I think the need resident in first phase of disaster COVID is need as a basic living, and we preserve for that. And then the significant factors in the implementation of social design require future conditions such as a leadership, community initiative, and collaborator. And for the sustainable program, sure, the relationship between the proposed program fosters sustainability, social bonds, and correct community involved in all project activities, and the needs of these projects going to the community is very important. The design outcome is the development of actor networks, and then the network actors in each step design process are various. We can find here, and whether we assume that stage 3 and 4 become very important. And the collaboration with the intermediate partners such as Arcom, it is an important role in the Bangkit Berbarengan program. We cannot do it by ourselves as an academician, and then therefore hand in hands with the NGO, we going and masuk going to the kampung. Creative communities can be associated with strong social ties between communities. This can be seen in the whole pre-implementation, project implementation, and project utilization. Therefore, that I can share for this evening session, Pak Seno and ladies and gentlemen. Thank you very much,
Ms. Kusuma, for your presentation. Okay, we next to Miss Tasya.
Okay, well.
Okay, Miss Tasya, the time is yours.
So Seno.
Yeah.
Can I just share my screen?
Okay, sure. Apakah bisa, Miss?
Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Tafsa, and I will show my result study for ecosystem conservation of mangrove education center in handling inundation disaster at Bangkalan Jambi Village based on stakeholder engagement perspective. Bangkali Strait on the east side, the first refining to research data belonging to Wahyu Purwanto 2020 Intelligent Study of Inundation Management in Bangkalan Jambi Village, Bangkalis District, states that the coastal line of Bangkalan Jambi Village has declined by 150 meters, or in the last 20 years, every year experienced a decline up to 5 meters. The abrasion that occurs is caused by the rampant illegal logging of mangroves and the lack of knowledge of community group in planting mangrove. For the reason, the formulation of the problem in this study is the first, how is the practice of developing and mangrove education center ecosystem conservation area on the coast of Bangkalan Jambi Village, and then how is the analysis of stakeholder involvement in the development of the mangrove education center ecosystem conservation area on the coast of Bangkalan Jambi Village. This is my result of the studies. The development of conservation has started from 2017 until now, where actors who have high influence and interest dominate the direction of the development of mangrove education center conservation area. There are three actors who play a role in the development of the mangrove education center conservation area, namely private sector Pertamina RU2 Sungai Paning, and then Pangkalan Jambi Village government, and then kelompok harapan bersama. After we identified the actors' involvement in the mangrove education center conservation activities in Pangkalan Jambi Village, it is necessary to analyze the influence and interest of each of this actor and their relationship with PT Kilang Pertamina International RU2 Sungai Paning. The result of the analysis are as follows. The first, private sector Pertamina RU2 Sungai Paning in the company intervention is the dominant factor in the development of the mangrove education center conservation area in Pangkalan Jambi Village, which until now has developed into an ecotourism area. This is evidenced by the company's guidance to coastal community group in Pangkalan Jambi Village through the implementation of CSR program since 2017. Community development funds have been distributed by the company to assist group in overcoming abrasion problem and overcoming the failure of mangrove planting due to lack of group knowledge. And there were innovation which were later developed by the company together with the group in the form of breakwaters, in the form of hybrid engineering with modification, and then the triangle mangrove barrier Trimba. The company has a very high influence due to the existence of the intense mentoring relationship with community group, making companies trusted by group to help them deal with abrasion disaster will helping to improve the company through the development of ecotourism. And then Pangkalan Jambi Village government, the influence that the Pangkalan Jambi Village Government Institute has is very high. This is because this institution has the responsibility to grant partnership permit between is because this institution has the responsibility between the Harapan Bersama group and companies or with other institutions and organization in effort to deal with abrasion disaster and empower group. The Pangkalan Jambi Village government also plays a role in providing input on the strategies and politics that will be taken by Pertamina RU2 Sungai Pakning in implementing CSR programs in the mangrove education center area. In addition, the Pangkalan Jambi village government also has the authority to issue policies that encourage mangrove conservation activities, always ask allocate village fund to support these activities. On the other hand, the interest of the Pangkalan Jambi village government is considered the very high seen from the gradual contribution in has made through the allocation of village funds aimed at supporting mangrove planting and ecotourism development in mangrove education center. And then Kelompok Harapan Bersama has a fairly high influence in expressing its appreciation to provide input the community development officer team and management regarding the planning and strategy for implementing CSR programs in the Mangrove Education Center area. The group also has a high interest in managing the Mangrove Education Center area of Pangkalan Jambi Village, where there is a periodic performance and success assessment of the implementation of the CSR program conducted by Pertamina RU2 Sungai Pakning, which is contained in the CSR monitoring and evaluation report. And then Bengkalis Residency Marine and Fisheries have this the department fairly high influence on the implementation of the conservation of the mangrove education center ecosystem in Pangkalan Jambi Village. This can be seen from the absence of regular guidance by this institution, so that the policy and strategies of Pertamina RU2 Sungai Pakning in the implementation of the CSR program do not have an inherent impact on this institution. On the other hand, the importance of this institution is considered quite high, seen from its of concern in 2019, which provided infrastructure assistance for fishing group to help improve infrastructure facilities when they wanted to go and return from fishing. And then environmental service, this institution has a high enough influence of the implementation of conservation and ecotourism activities and mangrove education center Pangkalan Jambi Village. This is because his presence is able to change the CSR implementation strategy of Pertamina RU2 Sungai Pakning with the assessment criteria in the program and Setiasari Bumi assessment categories. And then other office and ministries a fairly high influence and interest in the implementation of conservation and or ecotourism in the Mangrove Education Center area of Pangkalan Jambi Village. This is because the role and involvement of this institution is deemed sufficient to support mangrove conservation activities at Mangrove Education Center Pangkalan Jambi Village. However, the presence of this institution has no influence on the formulation of CSR policy and strategies carried out by Pertamina RU2 Sungai Pakning in the Mangrove Education Center area. And then Pertamina Pencipta Alam, University of Rio Public Administration Studi Program Forum Gambut Muda Forgada, Sekolah Cinta Gambut, and Geography Education Studi Program Faculty of Teacher Training and Education Universitas 11 Maret. This stakeholder group belongs to the category that has less high influence. This is because they are passive actors who were assigned by Pertamina RU2 Sungai Pakning to help enrich the knowledge of the Kelompok Harapan Bersama and the assist group outside of mangrove conservation and to help in the planting of mangroves. As for the level 2 importance, Patrapala has a low criteria because all conservation activities carried out by Pertamina RU2 Sungai Pakning through CSR development and biodiversity
do not have much impact on the continuity of activities in the Patra Parakup. On the other hand, the public administration studi program at the University of Riau, the Forum Gambut Muda, and then the Sekolah Cinta Gambut Network, and then the Geography Education Studi Program at the Faculty of Teacher Training and Education Universitas 11 Maret have criteria of a fairly high level of importance because all development and implementation activities of conservation are deemed sufficient important to them.
One more minute, Miss.
Oh, okay. Yeah. Okay. The conclusion from this research are programs and activities to support the conservation efforts of the Mangrove Education Center ecosystem in Pangkalan Jambi Village have involved the contributions of various cross-sectoral stakeholders. However, this involvement is still limited to stakeholders who are representative of actors from the government and civil society organization. As for the involvement of the private sector, it can be said that it is less heterogeneous, where only one actor plays a role and is actively involved in the conservation activities. This private actor is PT Kilang Pertamina International LU2 Production Sungai Pakni. Although many actors are involved, this is only able to contribute to the stakes of disaster management and the level of prevention, mitigation, recovery, and development. Will the states of emergency preparedness and response have not been provided by the company, either in the form of education and training, where the company is only limited to providing education related to the readiness and feasibility of ecotourism opening infrastructure that is safe for tourism, as well as providing tricks for groups to save tourists in the event of an accident such as drawing. Okay, that's all my presentation, Mr. Seno, and thank you for your attention.
Okay, thank you, Miss Tasya. Is there any question? Okay. If untuk for the presenter, okay. For the is there any question? If not, maybe this is the end. Okay, is there any question? Okay, if not any question, it is the end of the parallel session room 1. If the committee have mistake and also weakness, please forgive us for the mistaken and the weakness, and thank you for your presentation. Thank you for your presentation, and see you in maybe see you. Okay, This is the end of the parallel session, and thank you for your presentation, and see you in the ICoDMC 2 in 2023. And thank you very much.
Thank you, Mr. Seno.
Thank you, Mr. Wigharta Bekti.
Thank you, Mr. Seno.
Thank you,
Thank you,
everyone.
everyone.
Thank you, everyone.
See you in
ICoDMC 2022.
Amin. Thank you, Mr. Seno.
Okay.
Thank you, Mr. Seno. Halo,
Thank
Mbak.
you. Halo, Mbak Dewi. Thank you, Mbak Tasya. Terlambat datangnya.
Permit for live Zoom.
Okay, Mr.
No, I'm so sorry.
Yeah, it's okay.
Aku ketemunya sama Pak ya.
Iya. Thank you.